Given question, determine the reactions developed in overhanging beam.
Let us understand given diagram. This is the overhanging beam, and at point A it is hinged, and at point B roller support is given. So we can rotate this beam about point A. So we have to show the horizontal component and vertical component of this reaction at point A. But if we observe, all the forces are in vertical direction. No any force is in horizontal direction. So we have to take, or we have to consider only vertical component of the reaction at point A. So I will show here the reaction at point A, and we have to find out this. So this is RA, we will find out by the virtual work method. Now at point B, roller support is given and it is on the horizontal surface. So we have to show reaction perpendicular to this horizontal, that is in vertical direction, and we have to find out the value of RB. Now if we observe 10 Newton, 60 Newton and 30 Newton. These are the forces which are acting in vertically downward direction. Now how to find out the unknown values RA and RB? So there are two cases. Now in first case, we have to give small displacement at this end to the beam. Now these two are the unknown values. So when we give the small displacement at the end at the right hand side, then at the same time the displacement at point A should be 0. And in second case, we have to give the displacement at the left hand side, and when we give the displacement of the beam in left hand side in upward direction, then at the same time the displacement at this point B should be 0. So in first case, when we displace this end in vertical direction, so this will be very small displacement, and we will say that this displacement is delta y. So here is this end and here is the displacement delta y. So this is the original position and this is the final position. Now at the same time, here at end A, displacement should be 0. So we have to pass this line through point A, and here displacement is 0, so we have to show here that it's 0 displacement. Now what will happen, this beam is a straight line, so this end, that is the remaining end, will move in the downward direction, that is in the opposite direction to the displacement. So we will find out the displacement at 10 Newton force, 60 Newton force and 30 Newton. So at 30 Newton it is delta y. So for 10 Newton force, I will draw here one line. So this is the original position and here is the final position. So I will show this. So this is the displacement. Now at 60 Newton, I will show here, and at 30 Newton here is the delta y. Now at B, so at B RB is there, that is this is the reaction that we have to find out. So here also we have to find out the displacement. Now if we observe, at end A displacement is 0 and at this end displacement is delta y. So these two are the known terms. So what is the total distance in between this end A and this last end? 6 plus 2, that is equal to 8. So I will write here, this is distance 8 meter. So for this length of 8 meter, displacement given is delta y. So I will write here, for 8 meter delta y displacement is given. Now for 60 Newton force, so this 60 Newton force is placed at 4 meter from this end A. So I will show here this 60 Newton. So for 60 Newton force which is placed at 4 meter, so for 4 meter what is the displacement? Here is the question mark. So this is unknown term. So 8x is equal to 4 into delta y. So what is this value of x? So it is equal to 4 by 8. So 4 by 8, if we simplify this, then it is equal to half delta y. Now in the same way at point B we will find out. So at point B, here is the RB. We have to show this RB. Now what is the displacement? So B and point B is at a distance of 6 meter. So we have to measure the distance where the displacement is 0. So for the span of 6 meter, what is the displacement? Question mark. So 8x is equal to 6 into delta y. So value of x. So here 6 divided by 8 delta y. So if we simplify this, then here 3 by 4. 3 by 4 delta y. Now in the same way, if we observe, here is the span of 1 meter. So I will remove this. So span of 1 meter, what is the displacement? Here is question mark. So 1 delta y is equal to 8x. That is equal to 1 by 8 delta y. So I will write here 1 by 8 delta y. So it is in the downward direction. So if we observe, this displacement is in the opposite direction. Now this diagram is getting completed. Now we will move to the next case. So here we have to give the displacement at this right hand side, and this displacement is in the vertical direction. So we will say its displacement is delta y dash. So this is the original position and this is the final position. Now at this point, force is equal to 10 Newton. So we will show this. This force is 10 Newton, which is in downward direction. Now at point A, there is reaction RA. So we will show this reaction. So here RA we have to find out. Now we have to measure this displacement at end A. Now next is 60 Newton. So 60 Newton, for 60 Newton also we have to find out the displacement. And then for 30 Newton, so at this end 30 Newton, and we have to find out this displacement which is in the opposite direction. Now at end B we have to keep displacement is 0. So we will write here as a 0. Now if we observe from this 0 to this delta y dash, what is the total span? 6 plus 1, it is equal to 7 meter. Now if we observe this end A, what is the distance of this point A from this point B? Because from 0 we have to measure. So it is equal to 6. Now if we observe, here we have to write the equation for this total span of 7 meter. This total span of 7 meter, delta y dash is given. This is the small displacement. Now for point A, the distance is 6 meters, because we have to measure from this 0 what is the displacement. So here is the question mark. So it is equal to 6 by 7 delta y dash. Now in the same way for 60. So for 60, here this total distance is 6 minus 4, that is 2. So here the 60 Newton force is at 2 meter. So here 2 by 7 delta y dash. And now if we observe this 30 Newton, here is 2. So for 2 meter, what is the displacement? So it is in the opposite direction, but here we have to keep it the same, that is 2 by 7 delta y dash. Now this is the diagram. So at end B we have to show the action as it is. So it is equal to RB. Now we will apply virtual work method to find out the values of RA and RB. So sign convention is the important term. So the forces which are in upward direction, we will use positive sign. So I will write here for upward direction, we will use positive sign. And the forces which are in downward direction, we will use negative sign. And there is also displacement. So when this any point on the beam is displaced above its original position, then we have to take plus sign. So if we observe here, it is displaced above, that is in the upward direction of original place. So these are the with plus sign displacement. Now if we observe this end is displaced below the original position, so we have to use here negative sign. So I will mention only with negative term. So all are these are the positive signs. Now here in the same way these displacements are in the upward direction. So here positive sign and this displacement is in the downward direction. So we have to give here negative sign. When we apply virtual work method, we have to take force multiplied by that displacement, and we have to add all these forces by multiplying with displacement, and we have to equate it to 0. Now we will move to the first force. So here is 10 Newton which is in downward direction. So minus 10, and here also minus delta y by 8. So this minus will become plus. So we will write here 10 multiplied by delta y by 8. Now we will move to the second case. Now here at point A, reaction at point A is in upward direction. So we will take plus Ra multiplied by displacement, it is 0. Now we will move to the next force, that is 60 Newton. Now 60 is in the downward direction, so minus 60 multiplied by half delta y. Now we will move to the next is Rb. So it is in upward direction, so plus Rb into displacement 3 by 4 delta y. And next is 30 Newton. So here 30 Newton I will show this force 30 Newton. So it is in downward direction, so take negative sign, minus 30 into this delta y is equal to 0. Now we will simplify this. We will take delta y as a common term, and 10 by 8 minus 60 by 2 plus Rb into 3 by 4 minus 30 delta y is equal to 0. So delta y is very small displacement and delta y is not equal to 0. So we can transfer this term to the right hand side. So it will become 0. So only one unknown term Rb, and Rb is equal to 78.3 Newton. Now in the same way we will solve for the next diagram. So here 10 Newton force. So we will take all the forces from left towards the right hand side. So here is 10 Newton force which is in downward direction. So minus 10 multiplied by displacement delta y dash, minus 10 delta y dash. Now here Ra which is in upward direction, so plus Ra into 6 by 7 delta y dash. Now next is 60 Newton downward direction, minus 60 into 2 by 7 delta y dash. Now next is Rb which is in upward direction. So plus Rb into displacement is 0. Now next is 30. So it is in downward direction. So here minus 30 multiplied by, now this 2 by 7 delta y. So it is below the, or it is in the downward direction. Displacement is in the downward direction. So minus 2 by 7 delta y dash. So this minus will become plus. So and it is equal to 0. Now when we simplify this, again here delta y dash we have to take common, and delta y dash is not equal to 0. So we can transfer this term to the right hand side, and we can find out the value of Ra which is equal to 21.6 Newton.